All right, so you want to write some seriously impressive code. We're diving into the world of math and programming today, and let me tell you, this isn't just about your basic arithmetic.
Yeah, forget what you think you know.
We're talking about the kind of stuff that'll really make you a coding ninja, and we found this awesome blog post from the Dojo MX called, now get this, Las matemáticas que debes saber para programar.
Catchy title.
Right. And it's packed with some serious
It
insights.
is, like right off the bat, it challenges this whole idea that math and programming is all about complex formulas and equations.
Yeah.
It's more about grasping those core concepts behind even the simplest operations.
It's true, though, because we all use loops and stuff, right? But this post really made me stop and think, do I actually understand why a loop works the way it does? Or why one algorithm runs circles around another one?
It's like the difference between knowing how to bake a cake because you followed a recipe
Right.
and understanding why those ingredients work together to create that delicious masterpiece.
Hmm.
Programming is the same way. It's about truly getting those building blocks.
It's about going beyond just the how-to and really digging into the why.
Absolutely.
So the post uses this super interesting example of cryptography to drive that point home,
Yeah, cryptography.
which at first glance you might think, what does that have to do with everyday coding?
Right. Different worlds.
But they weave it in so cleverly to show how something like probability, something we usually associate with statisticians and stuff, is actually crucial for things like making strong encryption keys.
Yeah, for sure.
And that's what I find so fascinating about these deep dives we do, is that they uncover these hidden connections. Like, cryptography is this whole secret world inside our computers where math literally becomes the code to keeping information safe.
It really is.
And they gave this example of a 128-bit encryption key, which, I'm not going to lie, kind of blew my mind. 2 to the power of 128 possible combinations.
That's a lot.
How do you even wrap your head around a number that massive?
It's practically unfathomable. And that's the point, really. Think about a hacker trying to brute force their way through all those combinations.
Oh, man.
It would take them, well, let's just say a really, really long time, even with the most powerful computer imaginable.
So it's like you're using math to build this unbreakable digital fortress.
Exactly. That's the power of applying those concepts correctly.
And this is just the tip of the iceberg, right?
Oh, there's so much more.
Because the post goes on to talk about logic, which seems like a no-brainer, of course. Logic is important in programming. But then it goes deeper into this whole realm of what's called discrete mathematics.
Yeah, it gets pretty in-depth.
And suddenly I'm looking at those basic if-then-else statements we use every day in a whole new light. They're not just these simple commands, they're built on this entire foundation of logical principles.
It's all connected.
It all comes back to the math.
Exactly. And that's where truly understanding those core building blocks of logic, like your A and Ds or Rs, nots, can actually transform the way you write code.
Oh, interesting.
You can make it much more efficient, much more elegant, because you're working in sync with how the computer thinks. Because at its core, it's all based on these logical operations.
So it's not even just about knowing how to write the code, but really grasping the why behind its structure.
Right, the underlying why.
I love that. Then they go on to discuss sets, which I'll admit at first glance seemed a little out there.
Sets.
Like, how often are we really using set theory in our day-to-day coding?
It's definitely one of those areas that doesn't get a ton of attention, especially in those like beginner programming courses and stuff.
Right, exactly.
But it's a powerful tool. It can be super useful when you're working with databases.
Oh, interesting.
Think about SQL queries. Understanding sets can make those queries incredibly efficient.
So instead of picturing a database as just this massive spreadsheet,
Yeah, rows and columns.
sets help us see those relationships between different data points.
Exactly. Like, imagine you need to find all users who have, say, purchased a specific product, A and D, left a review.
Ooh, yeah.
That's a real-world application of set theory right there.
So cool.
It's so much more elegant than trying to write some clunky code that tries to filter through everything manually.
And probably way more efficient, too.
Oh, absolutely. Way more efficient.
It's like you unlock this whole other level of coding mastery or something.
Totally.
But speaking of unlocking secrets, the next part of this post delves into something that always kind of trips me up. Number systems.
Ah, yeah, the number system.
Binary, hexadecimal. It's like all of a sudden I'm back in high school math class, completely lost.
It can feel like a whole new language. I get it.
It really does.
But it's all about understanding the why, just like we've been talking about. We're used to our decimal system, 0 through 9. But computers, they think in binary. It's all zeros and ones for them.
Right, right. Zeros and ones. The language of computers.
Exactly. And once you wrap your head around that it's just a different way of representing information using those two digits, it becomes a lot less intimidating.
And the post actually does a really good job of breaking that down, I thought.
It does, yeah.
It's not just about memorizing how to convert decimal to binary. It's about really getting that each digit in binary, each one of those zeros and ones actually represents a power of 2.
Exactly. Like a light switch, it's either on or off, 1 or 0.
I like that.
And when you understand that, suddenly things like bitwise operations, memory allocation, they start to make so much more sense.
It's like you're seeing the Matrix or something.
Right. Those ones and zeros start to tell a story.
Exactly. Okay, so binary, I kind of get it. But then there's hexadecimal, which seems even more abstract. Why do we even need that if computers think in binary anyway?
So think of hexadecimal like a translator between us humans and the computer.
Okay.
Binary's super efficient for machines, right? But for us humans, let's be honest, it's not the easiest thing to read, especially when those numbers get really long.
So true.
Hexadecimal, with its base of 16, using those numbers 0 through 9 and then A through F, gives us this nice compact way to represent those long strings of binary.
So it's like a shorthand that both programmers and computers can understand.
Exactly. It's like that common language that bridges the gap. Each hexadecimal digit, it represents 4 binary digits. 4 of those ones and zeros. So it makes it way easier for us to write and understand code that's actually interacting with the computer's binary system.
That makes so much more sense now.
It's especially handy when you get into things like memory addressing or even color codes. You often see those expressed using hexadecimal.
Okay, yeah, that rings a bell. Wow. So we've talked about basic arithmetic, probability, logic, sets, and now even number systems.
That's a lot.
It feels like we've covered like a whole universe of math concepts just in this one blog post.
It's true. And the post acknowledges that certain programming fields, like if you're really diving into data science or AI,
Right.
they often require a deeper understanding of more advanced math. Things like linear algebra, calculus, even differential equations, that kind of stuff.
No, and that's where I start to get nervous, honestly. Like, AI is super interesting to me, but the math can feel really intimidating. Do I need to become like a math genius to even dip my toes into those waters?
That's a great question. And honestly, this is the reassuring part. While a really solid mathematical foundation is always going to be helpful, you don't necessarily need to be a math whiz to start exploring those fields, especially now, right?
Yeah.
We have such incredible tools and libraries available to us as programmers.
That's true. So it's more about understanding the concepts and knowing how to use the tools effectively.
Exactly.
It's like having the, what do they call it? The legend for
Remember
math.
called the legend, yeah.
You might not know every single little dirt road and path, but you can still find your way to where you need to go.
Exactly. And sometimes diving deeper into those specific applications, it can actually make those abstract mathematical concepts click into place, like cryptography, for example.
Oh, totally. Remember when we were talking about that crazy number of combinations with the 128-bit encryption key?
Yeah.
Well, the post mentioned something called trapdoor functions in cryptography, and it really piqued my interest.
Oh, trapdoor functions. It's a great analogy. Imagine like a box, right?
Okay.
It's got a lid, super easy to close slam, but trying to open it without the right key,
Oh,
nearly impossible. That's basically a trapdoor function, simple to compute one way, but reversing it. Good luck.
it's like trying to, I don't know, unmix cake batter or something.
Exactly.
Once it's all blended together, good luck separating those eggs and flour again.
Exactly. And that's why it's so powerful for encryption, because that whole principle of being easy to do one way, but incredibly hard to reverse.
Right.
That's what makes it so secure. And what's really cool is the post mentions that these trapdoor functions are often based on mathematical problems related to, you guessed it, sets.
Sets again. So how do they play into this whole cryptography puzzle?
Well, there's this famous problem in cryptography called the discrete logarithm problem. I'll spare you the technical details.
Okay.
But essentially, it's like trying to find this one specific value within a massive, massive set.
Okay.
It's almost like trying to find like a single grain of sand on an entire beach.
Oh, wow, yeah.
Except in this case, the beach is made up of all those possible combinations of that 128-bit key.
So even if a hacker had like the most powerful computer on the planet, it would still take them like forever to find that one grain of sand.
Pretty much. They'd be there for a very, very long time. And that's what makes it so secure. It's not just about making a complex password. It's about utilizing these inherent properties of these mathematical problems to create systems that are practically unbreakable with brute force alone.
It's like we're not just building a fortress, we're building it on a foundation of, like, mathematical laws.
Exactly.
This is blowing my mind. Suddenly, math doesn't seem like this abstract thing anymore. It's like the secret code to understanding how this whole digital world actually works.
That's what's so cool about it. It's about understanding those fundamental principles that govern information, logic, security. It all comes back to the math.
This deep dive has been amazing. For anyone listening who's ever felt that little bit of like, oh no, math, I highly recommend checking out the full blog post. We'll be sure to link it in the show notes.
Definitely. It's a great reminder that you don't have to be a math genius to be an amazing programmer, but expanding your math toolkit,
Oh, yeah.
it can really open up a world of possibilities.
Who knows, maybe one of our listeners will be the next cryptography superstar, all thanks to a little bit of math.
I love it.
Until next time, keep exploring, keep coding, and keep that curiosity burning bright.